Okay, so looking at number 4, our question tells us to suppose that more than a decade ago, high levels of lead in the blood puts 83% of children at risk. A concentrated effort was made to remove lead from the environment. Suppose, according to the survey, only 7% of children in the United States are at risk of high lead levels. In a random sample of 300 children taken more than a decade ago, what is the probability that 230 or more had high blood lead levels? All right, so in this case, child could either have high lead levels in the blood, or not have high lead levels in the blood. So this is a binomial probability. So we need to identify our number of trials, n. So n is equal to 300 children, because we took a sample of 300 children. P, our probability of success. So that means we need to figure out what is success. So in this case, the question's asking us, find the probability that 230 or more had high blood levels. So we're going to define success to be that a child had high lead blood levels. So in this case, P is going to be the probability that a child had high blood levels. So it's going to be P equals 0.83. All right, so Q is always equal to 1 minus P. So Q in this case is equal to 1 minus 0.83. So Q is equal to 0.17. All right, so we've got the three things we need from the binomial one. So the next thing we need to check is, okay, can we use a normal approximation for this binomial distribution? So we need to find out what n times p is. So n times p, in this case, is 300 times 0.83, which is equal to 249. And this is also our mean of our binomial. So NP is 249, and it's also our mean. And so to be able to use the continuity correction, NP has to be bigger than 5. 249 is certainly bigger than 5, so we're good. So next we need to check N times Q. Well, that's 300 times the 0.17, which is 51. Again, that's bigger than 5, so we're good. So because both NP and NQ are greater than 5, we can do a continuity correction. So next thing we need to find is our standard deviation. We already have our mean of our binomial. Our mean is going to be 249. This is also going to be the mean of the normal distribution. Our standard deviation of the binomial is going to be the standard deviation of the normal. So remember to find standard deviation of a binomial. It's square root of NPQ. So that's going to be the square root of n times p. We already know is 249. So 249 times 0.17. So that gives us the square root of 42.33. So our standard deviation then is 6.51. All right, so we've got mean, we've got standard deviation. We know we can do continuity correction. So next thing, let's write out the probability we're trying to find. So we're trying to find the probability that 230 or more children had high blood levels, right? So this is going to be the probability that R is greater than or equal to 230. So that means 230 or more. All right, so next thing we need to check, make sure we have equality on this probability. So we have greater than or equal to because it's 230 or more. We're good. So now we can go straight to our continuity correction. So we need to figure out, is 230 a left-hand endpoint or a right-hand endpoint? So we just sketch out a number line. So more than or equal to 230. So we're going to be going to the right-hand side of 230. So that's where all the numbers more than or equal to it are. So 230 is a left-hand endpoint. So because it's a left-hand endpoint, when we do our continuity correction, we're going to subtract. So we have to do some kind of calculation to convert from R to X, so from binomial to normal. So to do that, for a continuity correction, we're going to, because it's a left-hand endpoint, subtract 0.5 from the 230. So that gives us the probability that x now, so now we've changed from binomial to normal, so instead of being r, we're writing it in terms of x. X is greater than or equal to 229.5. So now we've got it converted to a normal distribution. We've made it continuous. But now we've got to take it to the standard normal distribution, or to the z-distribution. So to do that, we're going to convert to a z-score. So z is greater than or equal to, our z-score formula, remember, z is equal to x minus mu divided by sigma. So z is going to be greater than or equal to our x value of 229.5 minus our mean of 249 that we found, divided by our standard deviation that we found of 6.51. And so then when we do that calculation, that gives us probability z is greater than or equal to negative 3.00. So when you do it on your calculator, you should get negative 2.9953, which we only need 2 decimal places, because the 5 or more rounds up, rounds to 3.00, negative 3.00. All right, so how do we find this now? So now we're back to what we've done in chapter 6. So we've got probability z is greater than or equal to negative 3. So go to our z-score table. So negative 3.00. And find that probability. It's 0.0013. So then, because this is greater than or equal to, that's area to the right. So this is going to be equal to 1 minus the 0.0013 we found, which then gives us 0.9987. And that is the probability r is greater than or equal to 230.